Hello guys, I hope you all are doing good. In the last video, we have seen some basic concepts and applications of Arduino. Now, in this video, we will be seeing the structure of programming and basic example program for blinking an LED using Arduino. And we will also see the interfacing of LED with Arduino. Before this, let us see some basic Arduino boards that are available in local market or in online, or we can get them easily. Now let us go to the computer screen. Alright, the first board is an Arduino Uno. As you can see on the screen, this board is commonly used by so many people who are getting started with Arduino. And the next board is Arduino Nano. As you can see on the screen, this is the smaller version of Arduino Uno and it is little less expensive than Arduino Uno. Now let us move on to the last board, that is Arduino Mega. This is the higher version of Arduino Uno. Specifications and features wise, this board is much more better than Arduino Uno or Arduino Mega. But selection of these boards should be based on your application, like what will be the size of your code, how many number of pins you will be using or which will be required in your application. I hope up to here it is clear. Okay, now let's move on. Now we will compare the structure of C program with the code which we will be writing for Arduino. Now as you can see on the screen, this is the generalized structure of C program. Any program which is written using C language can be fit in the structure. So this is called as generalized structure. Okay, in this structure, first one is the preprocessor directives, also called as header files. I assume you guys have some basic knowledge of C. In that, you would have written #include studio.h, #include conio.h or #include math.h or etc. which come under this section. Okay, next one is comment lines. This is an optional one, but I recommend to write comments in front of your code, because if you refer the code after some time, these comments help you to recall what exactly that particular line of code doing in that program. Okay, next one is global declarations. Here we can declare the variables that are used in our programs. The main advantage of this is the variables that are declared under global declaration can be used anywhere in the main program. Okay, next one is main function. It is the main section of our program. From here, actual programming starts. Next one is local declaration of variables. Here also we will be declaring the variable, but the variables declared under this section are valid only in that particular section of code or within the curly braces in which the variable is declared. If we use these variables in other sections of the code, the compiler will throw an error. At this time, global declaration of variables comes handy. Okay, next under expressions and statements, we will be writing our actual logic and operations. Next one is user defined functions. By using these, we can define our own functions according to our need, and we can call these functions to do the intended operations. That's it about these structures. If you know these things, you can understand any C program. Alright, now in this slide, you are seeing the basic structure of Arduino program. As you can observe, here there is no variable declarations, nothing. It has only two main functions. One is void setup and another one is void loop. These two follow different operation modes or execution methodology. That is, the code which is written in void setup will be executed only once when the Arduino board power ups. Then only void loop will be executed repeatedly, like checking the status of input-output pins or sending some data or displaying a message. Anything like this operation will continue to execute until the board restarts. In this slide, you can see that how Arduino IDE software looks like. As I said, it opens with a default program structure. I hope up to now you guys understood all the basic or technical knowledge for writing a program. Now let us start with our first example program, that is blinking an LED using Arduino Uno. Here you see the code for Arduino to blink an LED. But before this, let us see the components and circuit connection for this first. We will interface using an simulator that we will be implement on hardware. Okay, for simulation purpose we are using ThinkerCAD, which is a free online simulator. Now I will show how to get started with ThinkerCAD. First open the Chrome, then search for ThinkerCAD. Then click on the first link that will be shown. Then sign up with your Google account, then this window will be opened. Next, let us start with our example. First, create one project. On that, then select circuit. It will open this window. Here you can see the variety of components that we can use with Arduino. Okay, now let's start with our interfacing an LED with Arduino. First, in the search bar, search for Arduino. Here we can see we got our Arduino. Then click on that, then move the cursor to the workspace. Then click to place the component. One thing you should remember about these pins is that the output or the input to the digital pins should be digital voltage, that is either high 5 volts or low ground. But we can use variable signals with analog pins. And one more thing is that the analog pins can be used as digital pins, but digital pins cannot be used as analog pins. Now we will connect a LED to Arduino, that is at digital pin 13. Because the default LED that is present on Arduino is connected to digital pin 13. For that, let us search for LED in the search bar. Now select the LED. Now move to the workspace. If you click on the LED, it will give an option to select the color of LED. Okay. Remember that you should not connect LED directly to the board because it may damage the LED. So that we will be using a resistor that is 1 kilo ohm along with LED. So for resistor, search for resistor in the search bar, then select the resistor and connect the resistor to anode terminal of LED. Since we know that anode is positive and cathode is negative, connect the cathode terminal to the ground and anode terminal to digital pin 13. Okay, interfacing is over now. Let's see the program. Okay, back to the program. Here we can see in the first line of the program, we are declaring a variable that is LED pin is equal to 13 of int data type. If we compare to structure of C, that is a global declaration. Similarly, what we did is declared a digital pin 13 as an digital pin, LED pin. Next one is void setup. Here we will define the pins, that is we will be telling the board whether the used pin is input to the Arduino board or output from the Arduino board. This is the syntax for declaring a pin mode. Here in LED pin field we will be writing the pin number, then in output we will be using input or output for specifying that particular pin as whether input pin or output pin. Since here LED is an output from Arduino, so we have written here as output. That means LED is an output pin. That means we are telling the microcontroller that LED is connected as output from Arduino. Next is void loop. This is the syntax for making an particular pin of Arduino high or low. Here in LED pin we will specify the pin number which we want to control, and in high or low represents the status of pin. Then we are using delay function to insert a delay of 1 second. Then after 1 second we are making the digital pin 13 to go low, that is turning off the LED. Then again inserting a delay for 1 second, and these 4 instructions will be executed until the board is turned off. Now let's copy this and paste in code section of ThinkerCAD. Change this to text, then click on continue. Here you can see that it automatically generated some code based on our connections. Let it be. We will paste our code here. That's it. Then click on start simulation. Here you can see the LED is blinking in 1 second interval. Follow the same step to implement on hardware. For that, go to Arduino IDE, create new file, then paste the same code, then verify the code. Here you can see done compiling. That means no errors. If there are any errors, recheck the code, then connect your Arduino to PC or laptop. After connecting your Arduino to PC or laptop, go to Tools in Arduino IDE, click on Port, then click on Port, then select the serial port. That is, here in my case it's COM6, it's showing as Arduino Uno. Select that, then go to Board, and then here you select Arduino Uno, and then here for programmer select AVRISP MK2. Okay, now our board is successfully connected to our PC. Now click on the Upload. Here you can see it's uploading. Yes, done uploading. Now here you can see the LED is blinking. As I said, the internal or default LED that is present on the Arduino is connected to digital pin 13. You can see in the video that the one more LED on the board is blinking along with the LED which we are connected to digital pin 13. That's it for this video. In the next video we will see about some sensors that can be used with Arduino. Until then, be motivated, keep learning. I will see you in the next video. Thank you.